Hello, everybody. In this video, we're going to talk about solving two-step equations. So a two-step equation contains two operations. And remember, an operation is like plus, minus, divide, and multiply. So to solve a two-step equation, we're going to use the inverse operation to cancel each of those steps out. And the major word there, besides cancel obviously, is inverse operation. It means we're going to do the opposite of whatever operation's happening. So we have our operations up here, plus, minus, divide, and multiply. We're going to do the opposite of them. So if we see adding, we're going to do the opposite and subtract. If we see subtraction, we're going to do the opposite and add. If we see division, we'll cancel that out with multiplication. And if we see multiplication, we'll cancel that out with division. So they want us to use the reverse order of operations. Because think about it, we're doing the inverse. We're doing the opposite of how you would normally solve an equation. So normally we use GEMDOS. But instead of GEMDOS, we'll be using SAD-MEG. So right here, I want everyone to write SAD-MEG. What SAD-MEG stands for, it is the order in which we solve these problems. And it is just GEMDOS in reverse. So first, you'll go ahead and cancel out any subtracting or adding. Then you'll cancel out any division or multiplication, followed by your exponents. And then finally, you'll go ahead and do your groups. So let's go ahead and solve our first problem. And I'm going to show you how to check your answer as well, because there's a cool way to check your answer. So our first problem says 7x plus 2 equals negative 12. Now, our goal is to get the x by itself. So what we're going to do first, and you're always step, I would recommend to put your bar down the center. Now, this bar represents our equal sign. And what you need to know is that an equal sign is like a scale. It's always balanced. We need to keep this scale balanced, both sides of the equation. So if we do something to one side, like if I add 1 to one side, I need to add 1 to the other side to stay balanced. So in this problem, I have 7x plus 2. So first, let's cancel out subtracting and adding. On the left side, where we want to get x by itself, I see a plus 2. I'm going to cancel that by doing the inverse. I'm going to subtract 2. And like I said, if this line in the middle is a scale, whatever I do to one side, I need to do the other. So if I'm subtracting 2 over here, I must subtract 2 over there. And then what I'll do is I'll just go and subtract the constants. So positive 2 minus 2 is 0. So that cancels it out. It ceases to exist. And I didn't do anything with 7x. So it's the only thing left on this left side. On the right side, negative 12 minus 2, that gets negative 14. So now I have the problem 7 times x equals negative 14. So once again, we're going to use the inverse operations. So we just did subtracting and adding. Is there division and multiplying? Yes. 7 times x is multiplying. We cancel out multiplication with division. So I will next divide by 7 on both sides. If I divide by 7 on both sides, 7 divided by 7 is 1. So I'm left with 1x, also known as just x. Remember, 1x is equal to just x. They're the same thing. So I have 1x, and then I have negative 14 divided by 7. That gets you the answer of negative 2. So we just solved this problem, and negative 2 is our final answer. What is nice about this is we could take what we know from evaluating our expressions, our last unit, and use that to check the answer. So up here we have the problem 7x plus 2 equals negative 12. So what we're going to do is we're going to take the 7x plus 2, and we're going to see if we plug in our answer negative 2 into this problem, do we actually get negative 12? So first we'll punch out x, and then we'll solve it like we normally would. 7 times negative 2 is negative 14. Negative 14 plus 2 is negative 12. So when we plugged in our answer, negative 2, into the equation, we actually got negative 12, which is what it was supposed to equal. So we know we did it right. Let's go do another one. So let's look at this problem on the top. Let's put our bar down. I have x minus 4 divided by negative 3. So once again, before I do anything, I put my bar down, and I'm going to remember SADMED. That's the order we're going to do things. So first, if we look at this, we have to realize this x minus 4 is a group, technically. So we cannot get rid of that negative 4 because it's part of a group, and the group is last. So we're not going to do anything with that group. We have subtraction or addition. We do not. We do have subtraction and addition inside of the parentheses, inside of the group up there, but groups are last, so we're going to save that. Next, we have division and multiplication. Yes. On the bottom, we have a number by itself, so it's not part of a group, and it's dividing. It's dividing negative 3. So the opposite of division is multiplication. So we're going to multiply by negative 3 on both sides. Now on the left side, if you divide a problem by negative 3 and then multiply it by negative 3, those are opposites. So they just cancel each other out. It's like taking a foot forward and a foot backwards. You didn't really go anywhere. We did not mess with x minus 4, so that is the only thing left that's going to come down. On the right side, if you do 6 times negative 3, you end up with the answer of positive 18. So now that we have x minus 4 and it's outside of its group, it's the only thing left. We can solve it. We have x minus 4. The only way to cancel out subtracting 4 would be to add 4. And if I do that, x minus 4, the plus 4 and minus 4s cancel out, equals 0, so they disappear. And x is the only thing left that comes down. If I did 18 plus 4, I get 22. So we have our answer of 22. But once again, we are going to plug in our answer to that problem, and we're going to see if we get negative 6. So I'm going to punch out x and rewrite the problem. I'm going to plug in 22. Now, I'm going to solve this, and if I get negative 6, that means we did it right. So first, I'll do 22 minus 4. That gets me 18. Then I have 18 over negative 3. If you divide those, you get the final answer of negative 6. So we know we did it right. Let's go down and look at our next one. So once again, let's put our bar down. Here, once again, we have a group of parentheses. So remember, we're going to save that for last. And then I'm going to work through the order of operations. So do we have subtracting and adding? I do see subtraction, but it's inside parentheses, so we're going to save it for last. Is there division or multiplication? Yes, they are multiplying by 9 right there. So we're going to do the opposite and divide by 9. We'll do that to both sides to stay balanced. Whatever happens on your left side, 9 divided by 9 is 1. So that really cancels out, because if I did 1 times anything, it doesn't change. So if I did 1 times x minus 2, it's just x minus 2. So really, they just cancel out. We'll bring down x minus 2 because that's the only thing left. 27 divided by 9 is 3. So next, now that I have nothing left but x minus 2, I'm going to cancel that out to get x by itself. They're subtracting. 2 is a negative number, so I'm going to add and get rid of that negative number. If I do that, negative 2 plus 2 equals 0, so that cancels out and disappears. X is the only thing left, so I brought it down. On the right side, 3 plus 2 is 5. Let's go and plug it in. Remember, we're going to plug it into this problem, and we're going to see if we get 27 as our answer. So we're going to do 9 times, and then in parentheses, 5 minus 2. So first I'll do 5 minus 2. That's 3. I end up with 9 times 3. 9 times 3 is 27, just like we wanted, so we know we did that correctly. We have one more problem we're going to go through. So this problem, I'm going to put my bar down the center. And the reason I wanted to show you this problem is because there's a fraction. And for fractions, we have to do something a little special. So first, we're going to look at this problem. We're always going to use SADMED. I always write it down to help myself. So look at the side your variable's on. It's on the left. And ask yourself, is there any subtracting and adding? I see adding. I see plus 1. It's not in a group. It's by itself. So I can get rid of it now. I cancel out adding by doing the opposite. I subtract 1. If I do that, plus 1 and minus 1 is 0, so it just disappears. I'm going to bring down my fraction. 9 divided by 5 times x. 10 minus 1 is 9. All right, so now I have my problem. So I have 9 minus 5, 9 divided by 5. This is really 9 divided by 5 times x. And that's why I just drew those parentheses there to show you that. They're actually multiplying. So in reality, what we are actually doing is we're really dividing by 9 over 5. But if you remember, when you divide a fraction, what you actually end up doing is multiplying and flipping that fraction upside down, which is known as the reciprocal. And that's how you kind of divide fractions. You flip them upside down and multiply. So if I flip the fraction upside down and I multiply, oops, I didn't flip it upside down. There you go. If I flip it upside down, meaning 5 goes up top and 9 goes down low, and I multiply, this actually ends up canceling out because 5 times 9 is 45. 9 times 5 is 45. And if you end up with 45 over 45, like we would there, well, 45 over 45 just ends up equaling 1. So we really just end up with 1x. And you could say 1x, but really 1x, as we talked about earlier, is just x. On the right side, I do got to multiply 5. Oops, I did that again. I have to multiply 5 over 9 because I did it on the last side to my 9 here. Now I'm going to put a 1 underneath this 9 so it becomes easier for me to multiply the fraction. If I did that, 9 times 5 is 45. 1 times 9 is 9. So I have the fraction 45 over 9. We all know if you simplify that, 45 divided by 9 will give me my final answer of 5. So fractions, I know that seemed like a lot. Really, the only thing you need to know is flip them upside down and multiply if you have an entire fraction and it's multiplied. Now let's see if we're right. Let's plug that in. I'm going to plug it into this problem, and we're going to see if we get 10 as an answer. So we'll do 9 divided by 5 times 5 plus 1. If you do 9 divided by 5, you're really doing 9 over 5 times 5 over 1. 9 times 5 is 45. 5 times 1 is 5. So you have 45 over 5 plus 1. 45 divided by 5 is 9. So you end up with 9 plus 1. 9 plus 1 is 10. So we did get 10. We did it correctly. 5 must be the answer. Thank you so much for watching. I can't wait to work with you guys on this. Please ask me if you have any questions.